Alright guys, we're at lesson 8 already for module 3, and we're going to focus on the similarity. So the first half of the module looked at similarity through just dilation, so how to dilate a shape to make it a similar shape, either a larger or a smaller version of that original shape. But now in lesson 8 we're going to look at focusing on how to prove that they are similar. So how can we prove that it has been dilated by a specific scale factor? And the way that we do that is using not only our new transformation of dilation, but our original 3 transformations, or those basic rigid motions of rotation, translation, and reflection. So to prove similarity, we are going to have to write down the sequence, like we did in module 1, of transformations that will map one figure to another. So in our first example, it tells us that we have triangle ABC that's been dilated from center O by a scale factor of 1/2. Okay, so we have our original ABC triangle, and they dilate it from our center by 1/2. So they took all of our ordered pairs, just like we've done the last few weeks, and dilated it by 1/2, and this is the new figure. Then they created a congruent figure using our basic rigid motions and moved that triangle here. So these two are congruent. These two are similar because they have a dilation of 1/2. We are trying to prove that a double prime, B double prime, C double prime, is similar to ABC. Now, to do that, the first thing we have to do in our sequence is get this to be the original size. So if it was originally dilated by 1/2, what would I do to get it back to its original size? Right? By now we should know, because we practiced this before the mid-module, that we do the reciprocal of the scale factor. So if it was multiplied by 1/2 to get it this size, we would multiply it by 2 to get it back to its original size. So the first part of our sequence would be to dilate it by a scale factor of 2. Now I went through and I wrote all the original coordinates for A double prime, B double prime, and C double prime. And I took all of those times our new scale factor of 2. So I got 22/8, 26/10, and 36. I just went through and multiplied every number by 2. And then I plot my new numbers. So now I have a shape that is similar to this one because it was dilated by 2, but it's the same size as my original figure. But I still haven't proved similarity because now I have to use my basic rigid motions to get this figure back to the original. So if I know that I need to slide it along this plane to get it back over here, I know that I have a basic rigid motion that doesn't change the shape or the size of a translation. Now before we would have said translate from A triple prime to A. Okay, but now that we're on a coordinate plane, we can use the actual numbers to tell us specifically how far we need to move it. So you pick any one point and you map it using a translation to that same point. So you can move C triple prime to C, B triple prime to B, or A triple prime to A. You'll get the same translation either way. And if you count each individual space, you're going to see that you need to go, you're going to translate left 20 units. So that would get me right here. Still not there yet. So here's the triangle after I just translate 20 units left. Now to map it exactly onto my original, I need to go down 2 units. Once I move this triangle down 2 units, it will be mapped exactly on my original triangle, which is exactly what we were trying to do. So first we would dilate by a scale factor of 2 to get it to be the original size again. Then we would translate to map it onto the original. Now we have proved that these two figures are similar, not just by looking, but by using our sequence of transformations. All right, so now in our first exercise, and this is in your binder if you would like to do this one with me in your binder, with that first example you need to make sure and write down the sequence that we had and any information that you need to take notes on from that first example. For this first exercise, it's the same basic direction. So we have an original ABC that was dilated by a scale factor of 1/2 to get the prime. They use their basic rigid motions now to get the double prime. And now we're asked to describe the sequence that gets the double prime back to the original. So the first thing I know I need to do is get it to be the same size. In order to get it to the same size, I'm going to have to do a dilation. So I'm going to have to first dilate by a scale factor of R equals what? If they chose 1/2 to go from the original to the prime, what would I do to get it back to the original? We would multiply it by 2. We would do the reciprocal. Okay, when I do that, I list my original coordinates for the double prime. I take all of those numbers times 2, and I have my new coordinates. So now I have my triple primes, because it's the third triangle from the original. And now I have to figure out how am I going to move this, now that it's the same size, back over here. Before I can decide if I need to rotate or reflect, first I just need to get them lined up. So I know I'm going to need to translate. And again, you just pick one point and match it up. So you can do B this time. So if we take B, we go to the left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we go left 12, but we're still not there because we need to go up 1, 2, 3, 4. So we need to translate left 12 units and up 4 units. If I do that with each of these points, this time it actually maps perfectly and I don't need a rotation or a reflection. I am completely done after I dilate by a scale factor of 2 and translate left 12 units and up 4 units. Alright, now it's your turn to try. So in the picture below, and this is the first problem set for lesson 8, the first problem in the problem set, if you want to turn there, it gives us the directions. It tells us that we have this original figure that has been dilated from center O with a scale factor of 4 to get our prime. They have used our basic rigid motions to produce a congruent triangle to the prime, which is the double prime. I want you guys to describe the sequence of dilation followed by your basic rigid motions that would map triangle D double prime, E double prime, F double prime back to the original DEF. Now that you've tried that, you can select either A, B, or C. See if those match what you have. If none of those match what you have, you might want to go back and look and see. Okay, if you weren't sure where to start, now you have a few to choose from to see which one would map the double prime back to the original. Alright, the next problem I want to look at is whether these two figures are similar. So how do we know if something's similar? We just talked about it. We have to be able to use a series of transformations that maps one figure to the next. Is there any way to map figure A to figure B using a dilation followed by any of the basic rigid motions? And of course your answer is no. If I dilate figure A, I'm still going to get a triangle. If I use any of the basic rigid motions, I'm still going to end up with a triangle. There is no way to change shapes and keep them similar figures. Alright, so now we're going to look at lesson 9. It goes right along with lesson 8 in describing those sequences that prove the similarity. So now, is it true if we know that ABC is similar to A prime, B prime, C prime, so that means is similar to, if I know that they are, I know that there was a dilation from the original to the prime, I know it was followed by basic rigid motions, do I also know that the prime is similar to the original? The answer to that is yes. Okay, we know they are the same shapes because we know that's what similar means. When we see that we know that they're similar, we know they're the same shape, just different size. And we know that that size was based on a specific scale factor. That's what makes them similar. So we know that we would just need to use the reciprocal of this specific scale factor to go from the original to the prime, then again from the prime to the original. We're going to have to use the reciprocal to get it back to its original size, but we can do that. The sequence is going to be different. Okay, you might have to translate a different number of units, you might have to rotate a different way or reflect, but we know that it's possible because we know the shapes are the same. We know there's a specific scale factor because we know that the similarity exists between the two. So the example previous to this, we talked about symmetric. I'm going to write that down here. This is a good note to take. Symmetric similarity. That's not how you spell similarity. All right, symmetric similarity, which meant that the original is similar to the prime, then the prime is also similar to the original. Okay, we can go back and forth between the two. Now, if you look at this one, we have all three of these triangles. We also have another type of similarity, and it's called transitive similarity. And it says that if we have an original that's similar to the prime, and we have an original that's similar to a double prime, then we know that the prime is also similar to the double prime. We know that all of them are going to be similar to each other if we can prove that one is similar to another. So if I can prove a sequence that takes me from the original to the prime, and I can prove a sequence that takes me from the original to the double prime, then I know that these two would also be similar because of the transitive property. All right, so in conclusion, we went through and we did lesson 8 and lesson 9 in this video. Lesson 8 was about the sequencing of transformations in order to prove if figures are similar using dilations and basic rigid motions. That is the actual proof that they are similar. We know that this symbol means is similar to. That's going to be an important note that you need to take. And then from that first part of the lesson, we know that we needed to complete that problem set, problem number 1. Okay? And I have a few options for you to choose from once you do so. Then in lesson 9, we briefly discovered this symmetric relation, which is if the original, is similar to the prime, then we know the prime is also similar to the original, and that it's transitive, which means that if the original is similar to the prime and the original is similar to the double prime, then we can make that connection between the prime and the double prime. But that's what I want you to do to finish the lesson 9. I want you in your own words to explain what that symmetric relation and transitive relation of similarity is in your own words. Have a great night.